Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahir Rahmanir Rahim. Welcome to today's physics class. Today is the fourth class on chapter 7, Waves and Sound. In the previous third class, we have defined what is wave. We discussed about the characteristics of wave, discussed about the types of wave. We can categorize waves either in mechanical or non-mechanical wave. We can also categorize waves into either longitudinal or transverse wave. We have also compared the features between transverse and longitudinal wave, and we also discussed about some quantities related to wave like amplitude, frequency, time period, etc. Inshallah, today in the fourth class we will analyze some wave related examples from your textbook. We will also have discussion on sound wave. We will define what is sound, how sound wave is propagated through air, and also we will have a demonstration called bell in a bell jar that will illustrate the necessity of a propagating medium for the propagation of sound wave. We will also discuss about the audible frequency range of sound for humans and the characteristics of sound wave. At first, in your book there is a figure 7.06, a wave with respect to position. A graph is given. From this graph you have to determine its amplitude, wavelength, time period, frequency and velocity. How to determine the amplitude of it? We have to calculate the distance from the equilibrium to the crest, that is 0.1 meter, so the amplitude is 0.1 meter. What is the wavelength? We have to take two equal phases, consecutive equal phases, and we have to determine how much change of position has taken place between these two consecutive same phase. So here we see these and these are the 2 points of equilibrium having the same phase, and the change of position is 2 meter, so the wavelength is 2 meter. What is the time period? Here in this graph there is no mention of time, so we can find out how much position has changed during one oscillation, but we cannot determine how much time has gone in one oscillation. So time period cannot be determined, and frequency is inverse of time period, that cannot be determined also. We cannot also determine the velocity because velocity requires an amount of time. Now we will analyze the figure 7.07 that illustrates a graph, a wave with respect to time. So from this we can understand what is the amplitude, 0.2 meter, what is the wavelength. Here when it performs one complete oscillation and reaches to this position, a time is given 2 seconds, but how much position change has taken place we cannot determine it. So the wavelength cannot be determined, but the time period can be determined, that is 2 seconds, and from this we can also determine the frequency, inverse of time period, that is 0.5 hertz, and the velocity cannot be determined because we don't know the wavelength. In the third graph we have two graphs, amplitude versus position and amplitude versus time graph for the same wave. From this we have to determine the amplitude, wavelength, time period, frequency and velocity, and from these two graphs we can inshallah determine all of these four quantities. For example, to determine the amplitude we can determine it as 0.1 meter. To determine the wavelength we have to take the first graph. To complete one oscillation it travels 1 meter, so the wavelength is 1 meter. To determine the time period we have to look after the second graph. For complete oscillation it takes 0.2 seconds, so the time period is 0.2 second. What is the frequency? Frequency is the inverse of time period, that is 5 hertz. What is the velocity? When we divide the wavelength by time period we can get the velocity of 5 meter per second. In the fourth graph, figure 7.09, phase of a wave at different positions. we have to determine the position of same phase. Here we see there are two crests, these and this, locating the position A and C. So A and C position have the same phase, they have the same phase of crest, but the position B has exactly the opposite phase of position A and C, and we cannot determine the phase in case of D and E. Now we will define what is called sound wave. Sound wave is a longitudinal mechanical wave that results from the back and forth vibration of the particles of a propagating medium. The propagating medium can be either solid iron or aluminium, liquid water, or gaseous air. Now we will understand a phenomenon: why is male voice deep while female voice is sharp. Now we will understand this phenomenon by a video. This video demonstrates how the vocal cords present in the larynx in our respiratory system, in our respiratory tract, vibrates to produce sound.
Phonation is the production of sound by structures in the upper respiratory tract. During exhalation, air passes from the lungs through the larynx.
So in the respiratory tract, we can talk, we can produce sound when the air is exhaled from the lungs, and when it passes through the airway, and when it vibrates these two vocal cords present in the larynx, then we hear the sound produced. And the production of sound can be modified by different ways. For example, here we see the two vocal cords are attached with two cartilage. This cartilage moves to produce different kind of vibration in the vocal cord, and the amount of air passing through the larynx also have an effect on the produced sound.
Muscles in the larynx can act to move the arytenoid cartilages that then move the cords. The cords are pushed together and air passes between them in such a way as to make them vibrate, creating sound. Greater tension in the vocal folds creates more rapid vibrations and high-pitched sounds. Lower tension causes slower vibration and a lower pitch. Sounds can also be altered by other factors. High pressure creates louder sound. Longer folds produce lower pitch sounds.
Here we see the anatomy of the larynx of male and female person. In case of male, we see the length of the vocal cord is longer, so that the produced sound by the vocal cord has low frequency. The sound is deeper, while in case of female larynx, the length of the vocal cord is shorter, so that it produces high frequency sounds, sharp sound. That is the reason behind why the male voice is deep and the female voice is sharp.
And shorter folds produce higher pitch. Structures in the oral and nasal cavities can also modify the sounds produced by the vocal fold.
Now we will understand how the sound wave propagates through air. We have discussed about it already. For example, there is a sound source or speaker, there is a vibrating object that is producing sound. So how the sound is propagating here? The vibrating object produces a oscillation to the surrounding air molecules. So the air molecules moves to and fro, oscillate in a simple harmonic motion manner, and transfers the energy to the next air molecule, and the next air molecule oscillates in simple harmonic motion and transfers the energy to the next particle, and by this process energy is transferred from one layer to another layer to another layer. Now we will demonstrate an experiment, bell in a bell jar, that illustrates the importance of having a propagating medium for the propagation of sound. This is a bell jar. Inside it there is a ringing bell. We can hear the sound because there is air inside the bell jar, so the sound can come through the air, then to the glass, then can go outside, and we can hear the sound. But what will happen if we can evacuate all the air inside the bell jar? So for this purpose there is a vacuum pump that will suck out all the air inside the bell jar. So then we will observe what happens then. Now the vacuum pump is started. We hear that the intensity of sound is decreasing because now there is a very much low amount of air to support the propagation of sound from the inside, and at a particular moment we will hear no sound because there is almost no air inside, so there is no air to support the propagation of sound now. Now what will happen if we allow the air to enter into the bell jar? Now he is allowing the bell jar to enter the air into it. So when air enters into the bell jar, now again we will hear the sound. So now you can hear the sound of bell coming from the bell jar because there is air to support the propagation of sound wave. So from this experiment we can understand that the presence of any kind of propagating medium is necessary for the propagation of sound. Now we will discuss about the audible sound frequency range for humans. We know that human can perceive sound greater than the frequency of 20 Hz and lesser than the frequency of 20,000 Hz. Any sound between this range can be perceived by human, and the other sound frequencies that is not inside this frequency range cannot be perceived by human. The sound frequencies less than 20 Hz is called the infrasonic sound, and the sound frequencies greater than 20,000 Hz is called ultrasonic sound. And the infrasonic sound can be perceived by some animals like elephants, whales, and they use infrasonic sounds for communication within their community. And these infrasonic sounds are also produced naturally during different natural calamities like earthquake or avalanche. And the ultrasonic sound is employed and produced by bats and dogs. Especially in case of bats, they produce ultrasonic sounds to find the path during their flying time. They produces ultrasonic sound and captures the echo that reflects from the obstacle, and from this they can calculate the free space along their path of motion. Now we will discuss about the characteristics of sound wave. Most of the characteristics are known to us already. Sound wave is a mechanical wave as well as there is a longitudinal wave. The air particles move in parallel direction with the direction of motion of sound wave. An elastic medium is required for the propagation of sound. If there is no medium present for propagation, sound cannot be propagated. And the velocity of sound depends on the property of the medium, and it also depends on the elasticity or tensility of the medium. If a medium is more tensile, then it will have higher velocity of sound. Velocity of sound increases with the increase of density of the medium. If we choose a denser medium, then the velocity of sound will increase. The velocity of sound also depends on the temperature. With increase of temperature, there is increase in velocity of sound. For per degree Celsius increase of temperature, there is increase of velocity of sound in air by 0.6 meter per second. And also humidity plays a great role on the velocity of sound in air. Reflection and superposition, they're the properties of any kind of wave, and they are also the properties in case of sound wave. And the sound energy is proportional to the square of amplitude. We know the relation already, E proportional A square. Now we will solve an example from the textbook, page number 202. The question is, sound of frequency 1 kHz is produced by a tuning fork. What is tuning fork? Tuning fork is a metal piece, U-shaped, that is made in such a way that produces a sound of particular frequency every time. So that can be brought from the market, scientific stores, and there are different types of tuning forks. For example, this tuning fork produces sound frequency of 1 kHz. There may be other tuning fork that produces sound of frequency 512 Hz. So you can find tuning forks of different frequencies. So this tuning fork is designed to produce 1 kHz sound frequency, and the sound produced from it now passes through air, water, and iron. The velocity of sound in air is 334 meter per second. In air, the velocity is 1493 meter per second, and in iron is 5130 meter per second. We have to determine what are the wavelengths in this three medium. When we want to determine the wavelength, we have to divide the velocity by frequency. So in case of air, when we divide the 334 meter per second by 1 kilohertz, that means 1000 hertz, we get the wavelength in air as 0.334 meter. In case of water, we find the wavelength of 1.493 meter. In case of iron, we get the wavelength of 5.13 meter. So here we see, as more denser medium is there, there is the wavelength of higher length, so the wavelength increases. As a result, the velocity also increases. So what we have learned today, let's revise. We analyzed some wave related examples from the textbook, and we also discussed on sound wave. We provided a definition. Then we also discussed how sound wave is propagated through air, and we performed a demonstration experiment in a bell jar that illustrates the essentiality of a propagating medium for the propagation of sound and the audible sound frequency range for human and the characteristics of sound wave. At the end of today's class, you have a homework. Write the characteristics of sound wave. আজকের মতো ক্লাস এখানেই শেষ। সবাই ভালো থাকো ইনশাআল্লাহ। সুবহানাকা আল্লাহুম্মা ওয়া বিহামদিকা আশহাদু আল্লা ইলাহা ইল্লা আনতা আস্তাগফিরুকা ওয়া আতুবু ইলাইক। আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহি ওয়া বারাকাতুহু।